it is my pleasure to introduce our next and final guest speaker for this afternoon. I have 2 cats at home, and my cats are under NSA grade video surveillance. Because, we're often away from home, and they are prone to mischief. It turns out that I just use a regular old kind of generic web-connected camera with just a little bit of computer vision in it, and it isn't really awesome for this application because it doesn't really know what a cat is, and it doesn't really allow me to interact with my cats, except that I can try and speak to them through my mobile phone through a tiny, tinny little speaker in the camera, and they're looking around, wondering what is going on here. It doesn't really have any impact. It turns out there's a huge opportunity here, and we're going to hear from Alex Neskin of PetCube. And PetCube has already made tremendous progress in this space of intelligent cameras for pet owners. So Alex, welcome. Thanks for being here.
Thank you, Jeff. Thanks for introduction. Thanks for inviting and giving an opportunity to talk on this forum about kitties and puppies, because that's important. So my name is Alex. I'm CTO and co-founder of PetCube. In a PetCube, we're connecting, I like to say that in PetCube, we're connecting pets to the internet. Obviously, we're making the best-selling cameras that allows you to watch, talk, entertain, and play with your pets, with your cats and dogs. The pet cameras take off in this pet industry, not surprisingly. I think like regular parents, they caring about babies, their their children. The same pet parents, they are worrying about what's happening with their pets. So we're solving this problem with the help of technology. This is a product that we recently launched to the market. It's called PetCube Bites. It's a camera with a treat dispenser. So you can put dog, cat food inside, and with your phone, with the mobile application, you can see what's happening in your room, and then you can treat your cat or dog who's just like fleeing the treat. So how it actually works. And the fun part about this, if you ever played Angry Birds, it does the same. So you can change the force with which you are fleeing the treats. So it's also entertainment for the pet parents. How big is this thing? 65% of US households, they have at least one pet. And this is tremendous growth if we compare with 2012, when there was only 56% of US households owning at least one pet. In 2016, the whole pet industry in the world were over $100 billion. And the biggest chunk of it is in the US market. And if you take a look at this chart, you can see that the industry shows over the last 2 decades, it shows a steady growth of 5% year over the year. And another interesting fact that 95% of US owners, they committed or they tended to say that their pet is a part of the family. So they are treating their pets as a babies. Obviously, cats and dogs, they are like the biggest category of pets that were adopted by US households. Another interesting fact is that On average, a pet parent in the US spending about $1,200 per year for their pet. And they're spending for food, vet care, different supplies. 5 years ago, when we started this business, we understand that for the last 50 years, there were no innovation on this market. And actually, with our first product, which called PetCube Play, we created a whole new category. We call it connected pets or pet tech. And eventually, we even created a dedicated shelf in the stores like Best Buy, Nordstrom, Brookstone. So I brought it here with me. This is the same camera. It looks like a tiny aluminum box with a speaker, microphone, camera. And the fun thing here, we have a laser inside. Yeah, and it works pretty good too. So basically, you can swipe your finger on the screen, and your cat or dog can react. It can chase the laser. So at the beginning, when the idea comes to me at first, I thought I created this prototype, and I thought, okay, I'm too lazy engineer to build kind of artificial intelligence to play with my cat and dog. So I need to crowdsource this intelligence from my friends. So I've made a Facebook application where all of them can just log into my camera and play with the cat and dog, play with my dog. That was the beginning. But eventually, we realized that our customers, and we've sold more than 150,000 units so far, they're also busy at work, and they cannot play with their pets all the day long. So we created kind of autoplay mode that can entertain your pet while you're not at home with a computer, with the help of computer vision. And as all hardware product, hardware product is only the beginning. Once the hardware product is in place, the next step is a software innovation. So the third product that we launched a year ago, we call it PetCube Care, and this is a cloud video storage for anything that happened in your home, in your room with your cat and dog. And you can receive some notification based on the motion detection or sound alerts, like if your dog is barking too much, for example. So for the PetCube Care, today I want to talk about the future of this technology and what we're going to do, what we're already done with it, and what are the challenges that we're facing as a product company trying to incorporate vision inside of our technology. So we call it giving a pet a voice. Of course, we have a lot of cameras. We have a lot of public cameras in shelters, and we are able to gather the biggest portion or the most of the data from extract from these cameras. And the first step with what we're doing right now is we're just detecting the object and analyzing the movement of this object. So we can compare, for example, like this month your cat was active n times. The past month it was n+2. Maybe something wrong with this month with your pet. And provide valuable information, advice to pet parents. The same when, for example, a person appeared at the frame. We can detect that, and combining the information about the person and pet, we can also provide information to the owner, like your pet, someone walked your pet, or things like this. As a regular parents, everyone, I think, they're worrying about their children when they're leaving them with nuns or just home alone. So the same pet parents, they are concerned. But the problem with the pets that the child eventually it can speak. It can tell about the problems that he or she facing, but that will not happen with a pet. Pet need a translator. And the next step for the care technology that we have, we see is an emotion detection, and apparently it's not that hard, and sometimes even easier to detect pet emotion compared with a human emotion. So we're working with shelters, research behaviorists to analyze and categorize different pet emotions based on the different type of posture. There are things like ear movements, tail movements, skeleton movements that by analyzing can be translated into some meaningful information for dog owners and cat owners. The thing that is happening right now and what we are doing is what we call like pet selfie detection, right? So if the cat comes close to the camera, we can detect the face of the cat and send kind of notification to your phone, and this is interaction from the other side. So based on this, I want to talk about the constraints that or challenges that we are facing right now. Those are three majors that I just put here and want to highlight. The first one is computing bottleneck. The second one is porting and optimization of the models. And the third one is obviously the system cost, because we're selling this product for like $199 in Best Buy, Nordstrom, and other stores. And we want to have a good margin to earn money, right? So for the computing bottleneck, of course, the main challenge for machine learning is to reduce or make an algorithms to provide like the better performance, the better accuracy, and in the smallest possible way. But the networks that exist at this moment, it's really hard to run them on just a single core ARM-based CPU, which we are having. And by the way, the previous video with the pet selfie, we're using like object detection, then we're using small network to detect the cat or dog or human or other things. Basically, that's 4 classes only. It's running on the single core CPU ARM-based without any DSP, GPU, and stuff like this. But once we train this network, once we like make it smaller, we're reducing the accuracy of the network. At this moment, it's kind of enough. But if we're thinking about future when we need to detect not only like cat or dog, but make a difference between terrier and Chihuahua, for example, that's where we need better models or better optimized models for our embedded hardware. The second thing is porting and optimization. So there are a bunch of frameworks that optimized for accuracy rather than run it for embedded, that's training the models for embedded devices. And we've seen a couple of solutions that are actually providing this for embedded devices. But the problem is that we're still lacking of open source solution for them, so we cannot evaluate them or use them before we actually buy them. And for the porting, like in our products, we're using different hardware platforms. And in order to support all of this zoo of platforms, we need to, on the same level of accuracy and time, it's harder for us as a development team to adjust model to different platform to make the same accuracy and timing among all of these platforms. And in the future, for example, if we're using different, more powerful platform, we want to save the backward compatibility, but we don't want to retrain the model completely, which makes a lot of time, consume a lot of time. And the third thing is obviously the cost. So here I want to walk you through the basic or average unit economic. I think for all of the, or most of the IoT products, and especially for PetCube. So let's say that you're selling the product for $200 in a retail price. Most of the Chinese manufacturers or investors in the valley will say, like, if your BOM is a quarter of that price, then it's good, you're earning money. But what does it mean that the device cost is $50? That includes like mechanical parts, electronics part, assembly fee, and we have very little amount to spend on the actually platform that can handle complicated computation to do the computer vision and deep learning. So this is a constraint. There are already some solutions like affordable platforms with the DSPs that we're using. However, still, I think we're not there to run like a big networks with a lot of classificators rather than just cat, dog, and human. So again, right now, some of the computation, we found a solution that some of the computation we can do in the cloud to save money and just not to save money, but enter the market faster. However, we see the future when all of the computation will come from the cloud to the edge device. So it will be not only cost efficient, but also private. I think most of the customers right now, they do not understand that all the video actually stored on the cloud, and if someone will compromise the cloud, then all of their video can be compromised. And with storing the video data on the device, we're able to secure the customer. And of course, the low latency. The same story as like a car when it's driving on the street. You don't want to like detect the stop sign, send it to the cloud, and then recognize and the result back. The same for us. When you're playing with the laser or the device playing with the laser automatically, you don't want the laser to point to the window and then realize that your cat jumped out of this window. So that's where the technology can help us. Yeah, that was the brief and short overview of what we're doing and what we are up. So thanks.